So the decisions must be made about how to replace the flood protection and prevent the type of devastation that occurred. These decisions are based on myriad factors and certainly have many social and political consequences. There is no way to do justice in this type of problem in this text, but it is a fictitious example based on the data available in the popular press will be used. So plans must be put into place to protect life and property in and around the city of New Orleans in the event of another hurricane event such as Katrina. Interestingly, the hurricane was not, so this is actually taken from, I don't know if it's Turkin or Sullivan. The hurricane was not one of the most powerful and had been downgraded to a Category 3 storm when she made landfall. This speaks to a more urgent need, knowing that the devastation could have been worse. So assume that after using the non-compensatory models, three primary alternatives remain available as given below. So ang ginawa dito pala is, kunwari nag-start na tayong maggawa ng non-compensatory models, and then upon or after the non-compensatory models, hindi pa rin tayo makapag-decide kasi according to lexicography, equal pa rin sila lahat. Wala tayong pwedeng i-decide doon. Or according to this, lahat ng dominance check, satisfying, lahat ng alternatives na natira would just have the same level. So we can do compensatory models in this case. And then also shown in the table are a number of attributes to be considered in making the decision about which alternative to select. So again, pag sinabi natin compensatory models, we're setting a certain level, let's say from 0 to 100 to all the attributes with the common denominator of the scale. So unlike dun sa ating satisficing model sa non-compensatory model na meron tayong mga certain minimum maximum value pero they have their own parang levels, diba? For compensatory models, since we're allowing trade-off here, we have the same scale of weights na we can assign. So in reality, of course, there would likely be more alternatives and variational alternatives available after initial analysis and many more attributes to consider. So we will use the additive weighting technique to recommend a course of action. So in this case, so compensatory model tayo under weighting technique. So yun. So here's the table of the attributes: cost, time until completion, environmental impact, resident confidence, category, economic development, and then standard levee repair, massive levee construction, and then restoration and restructure through non-structural methods. So ito yung mga levels nila, no? And then the following table contains ordinal ranking and the resulting weights of the various attributes. So sabi natin kasi kanina, so additive weighting technique. So, ginagawa natin dito is nag-a-assign tayo ng certain weights to a certain attribute. And to do that, what we have to do is to do the ordinal ranking based on the preference na gusto mo. So, in this case, ilan ba yung attributes natin? We have 1, 2, 3, 4, 5, 6. So, we have 6 attributes and then we have already assigned yung mga ranking nila, and the most significant attribute is the cost. So that goes with 6 and then followed by the category of hurricane alternative. So 5 and then 4, 3, 2, 1. So nakikita nyo naman sa ordinal ranking. So the weight would be determined based on the ordinal ranking divided by the total sum of the ranking. So you have 6 plus 3 plus 4 plus 2 plus 5 plus 1 equals 21. So 6 over 21 is 0.29, 0.14, 0.19, and then so on. So that is how you write the weight of each attribute. For example, nagawa tayo ng additive weighting technique dito sa number 1. And then you follow the same ordinal ranking based on the lexicography. So in this case, you will be having the rank, let's say this one. The weight of this cost would be 3 divided by 3 plus 2 plus 1 plus 0 plus 4. So ganun yung magiging weight niya. So in this case, we already have the weights of the attributes, and then the next one is that we write the value for each one of them. So the attribute is the cost. Okay, so the rating procedure is 35 minus cost over 33.7. So saan ba nakuha tong rating procedure? We could go back to this part in the handout. Let's say it's around here. The rating based on the non-dimensional scaling, it says here that the rating is equal to the worst outcome minus the outcome being made dimensionless divided by the difference between the worst and the best outcome. So in this case, we could just say that 35 is the worst outcome because yun yung pinakamataas na value, di ba? And then, ano ba yung minus cost? So, itong minus cost na to, so ito pa yung dito mo isasubstitute ngayon yung values na nilagay natin dito. And then, we divide this by the difference between the worst and the best value. So in this case, ano ba yung worst? That's 35 and then minus 1.3. So it gives you 33.7. So therefore, to get the first dimension, a less value, so you'll be getting, for example, this one. So it's 35 minus, ano ba yung value? That's 1.3 divided by 33.7. So this gives you 33.7 over 33.7, which gives you 1. Okay, so for the next one, we have, let's say, 20. So we have 35 minus 20 divided by 33.7. So this gives you 0.45. So ganun ang pagko-compute ng lahat ng dimensionless value. So you'll be doing that until the last part of the attribute. So yung value again, the value is ito mismo yung galing sa table. Okay, galing yan mismo sa table. Then yung rating procedure, this is based on the worst value minus yung variable, okay, divided by the difference between the worst value minus the best value. So, ganun siya. Rating procedure is a formula. Remember, this is a formula. So, yung inyong magiging sagot dito is the dimensionless value, which is actually the rating. You might be thinking, paano naman itong low, moderate, high na to? So, you would be thinking yung tinatawag natin na relative rank. So, for example, 3 yung ating highest na or yung worst dito. So, you could just say na yung ano ba yung pinaka gusto mo sa environmental impact. So, di ba yung gusto natin sa environmental impact, we have a low environmental impact. So, you could just say na this would be your 1, okay? So, this would be your 2, and this would be your 3. So, worst would be 3 minus the relative rank. Let's say, for example, this one. So, 1 yan, and then you divide this by the difference between 3 and 1. So, that's 2. That's why this is 1. Okay, so ganun yung gagawin nyo based on the ordinal ranking ng mga values na hindi natin mabigyan ng numerical value. So, ganun din sa economic development, low, moderate, high. So, you should always be using, kung ginamit mo kanina is low is 1, so, yung parang, if it's negative for the first attribute, so dapat maging negative din siya sa first attribute. So, ayun. Basta ang ano lang dito, ang formula lang natin lagi is parang worst outcome minus the value over the best, worst outcome minus the best outcome. So, this is interchanging based on the current scenario. So, for example, if the worst outcome is always higher, so you have worst outcome minus the value. But if the worst outcome is lesser, for example, in this, nasan ba yun? So, resident confidence, let's say. So, yung resident confidence natin, di ba, the resident confidence, kung mas mataas siya, is mas okay. So, therefore, since ang ating worst is the lesser value, so you would be writing yung confidence as the one that it comes first before the worst, or the, yun nga, before the worst outcome here, which is the resident's confidence. So, ganun yung nangyayari lagi. So, yun. And then you can have the dimensionless values. So, after that, after doing the dimensionless values, so you have the weights here, cost. So, you would be writing yung standard Levy pair natin na performance. So, 1, 1.5, 0, 0.5. So, the weight value would be the product of weights and performance. So, gawin mo lang dyan, after mo ma-complete yung performance based on the rating that you've already obtained, so multiply lang natin siya based on their weights. So, times, and then you'll be getting this. And therefore, yung magiging score nung weight value of standard Levy pair would be 0.55. Then you'll be using the same concept here. Just multiply with the weights. So that's 0. 0.15 times 0.14. So that's 0.021. And then let's say ito, 1 times 0.24. So 0.24. And then the sum would be 0.401. And then finally, you should be solving for the last, which is the restoration and restructure through non-structural methods. And then ito yon. And then the sum would be 0.606. So, yun na, given the scaling and weights used, the decision would be restoration and restructure through non-structural methods. So, yun yung pipiliin mo kasi yun yung highest the total score. Okay, so that ends the discussion for our final. So, in short, yung ating average weighting technique is the parang most complicated dito sa lahat ng methods kasi after doing the ordinal ranking and then taking all the weights, you will be determining each dimensionless value for based on the rating procedures, and then after the rating procedures you multiply it by the weights, and then the weighted value would be added. So yung pinakamataas na weighted value, then that would be your yun, parang best option mo. So again, itong mga rating procedures, so kinukuha yan based dun sa formula natin na nandito. Rating is equal to worst outcome minus outcome being may dimensionless over worst outcome minus the best outcome. Pero syempre, if the designation of worst outcome and outcome being may dimensional changes depending on the problem. So pwede siyang mauna to or pwedeng mahuli to. Basta laging worst outcome yung nasa taas. Okay, so yun na lang, and I guess I'll be seeing you on the last week of the of this month. Basta yung last week nung semester. Okay, so yun na yun, and stay safe.